Assume that C of X is the cost to create products for a business. R of X is the revenue from selling the products, and P of X is the profit, or revenue minus cost. If X represents the number of products created in hundreds, what production level will maximize profit for the functions provided below? Our revenue function R of X is equal to 15x, and our cost equation C of X is equal to x to the third minus 3x squared plus 9x. Well, the first step when solving optimization problems is to assign variables to unknown quantities and draw pictures if needed. Well, since this is a profit or revenue minus cost problem, we don't really need to draw any pictures. So let's go on to the next step, which is to define the constraints for your variables, if there are any. Well, the constraints for our x values, x is going to have to be greater than 0 because otherwise the revenue is going to be negative. And negative products would not make sense within the given situation. Step number 3 is to decide on the equation that needs to be maximized or minimized and write that equation in terms of only one variable. Well, we're looking for the profit to be maximized, and profit is revenue minus cost, or P of X is equal to R of X minus C of X. And now we can substitute R of X and C of X into our profit formula. And then from here, we're going to simplify our profit function. We're going to take our -1 that's outside and we're going to distribute it through to all three of our terms. So we would have that P of X can be written as 15x minus x to the third plus 3x squared minus 9x. And now we have a 15x and a -9x. They can be combined together to be 6x. We're still going to have the negative x to the third and the plus 3x squared, but then we're going to have plus 6x at the end. The next step when solving optimization problems is to find the derivative in order to find the maximum or minimum value desired. So if we take the derivative of our profit function using the power rule, we'll get that p prime of x is equal to 3x squared, negative 3x squared, plus 6x plus 6. And then if we set this equal to 0, we can then solve for our critical values. If we do factor out a -3 here, we will have x squared minus 2x minus 2 is equal to 0. Are there factors of -2 that add up to -2? No. So we're going to have to use either the quadratic formula or graphing and finding the zeros from the graph. Either of those approaches could be used. And I'm going to switch over and graph this on a graphing calculator. And the graph of our function looks something like this. And we do have two zeros. We have negative 732 thousandths, and we have 2 and 732 thousandths. Well, since our x value has to be positive, this one can be ruled out. Now let's look back at our problem to see what the question is asking. If x represents the number of products created in hundreds, what production level will maximize the profit for our functions? Well, we know it is 2 and 732 thousandths. And then if we were to find the second derivative of our function, p double prime of x, it's going to be -6x plus 6. And if we substitute the 2 and 732 thousandths in for x, we're going to get 13 and -13 and change plus 6. We'll have -7 and change. So this is going to be a negative value, meaning it is concave down. And that also tells us that we are going to have a maximum value. So that is where the solution provides us a maximized profit. So from our answer choices, that's answer choice C, 2 and 732 thousandths 100 units.